If measurement feels easy until the exam starts throwing tricky scenarios, you're not alone. Most candidates miss points because they pick the wrong measurement method for the behavior they're actually trying to capture. In this video, I'll walk you through the exact thinking you need for Domain C so you can define behavior clearly, choose the right measures, and avoid common traps with continuous and discontinuous data. And if you want extra practice with realistic vignettes and data questions, check out bcbamuckexam.com for exam-style mocks with explanations. Here's the simple 4-step system I want you to use on every measurement question. First, identify the critical dimension the question is targeting. Second, select the measure that best matches that dimension. Third, check real-world constraints like time, staff, and setting. And fourth, remember which procedures tend to overestimate or underestimate behavior, because the fastest way to lose points is to pick a measure that doesn't fit the behavior's true dimension. Think of today as a guided path through 6 skills. We start by making behavior measurable with operational definitions. Then we sort measurement into direct, indirect, and product measures. Then we handle occurrence and time-based dimensions like duration, latency, and IRT. And finally, we zoom out to continuous versus discontinuous procedures and how to design sampling systems that stay practical without distorting your interpretation. Operational definitions are the foundation of everything. If 2 people can't watch the same situation and agree on what counts as the behavior, your data won't guide decisions. A strong definition stays objective and observable, includes clear boundaries for what counts and what doesn't, and is written in a way that actually supports reliable measurement and treatment choices. There are 2 common ways you'll see definitions written. One focuses on topography, what the behavior looks or sounds like, often with start-stop rules based on form, and the other adds context cues while still keeping the definition observable. The trap to avoid is mentalistic language like defiant or anxious, because if you can't literally see or hear it, it's not operational. On the exam, vague labels are a red flag. Terms like aggression or non-compliance are not enough because they don't tell you the exact observable actions or the boundaries. What earns points is a definition that names the visible behavior, includes measurable boundaries, and uses start-stop rules so it's clear when an episode begins and ends, like the progression from aggression to a specific set of contact behaviors observed within a defined session. If you ever feel stuck, use a quick template. Give the behavior a neutral name, describe what it looks like, specify exactly when it counts as starting, specify exactly when it counts as ending, and list exclusions. Because those start-stop rules are what reduce ambiguity and improve agreement between observers. Now let's make this real. When you see words like tantrum, off-task, or property destruction, your job is to translate them into observables with boundaries. What topographies are included, what signals the start, what signals the stop, and what does not count. On the exam, that translation step is often the hidden skill behind easy questions. Next, measurement types. Your first decision is whether you're directly observing behavior, collecting indirect report information, or measuring a permanent product. A quick exam rule is, if you did not directly observe the response happening, then it's not a direct measure, even if the information feels detailed. Direct measurement is your gold standard because it supports accurate treatment decisions and stronger agreement between observers. It can include count or rate, timing measures like duration, latency, IRT, and even interval procedures. But the trade-off is that it requires trained observers and time, so you always balance accuracy with feasibility. Indirect measurement is report-based. Think interviews, questionnaires, and rating scales, and it can be useful for screening, learning history, or understanding perception. The limitation is bias. So on the exam, you should treat indirect data as helpful context, not proof of behavior change, or a substitute for direct measurement of intervention effects. Product measurement focuses on outcomes left behind by behavior, like worksheets completed correctly or the number of damaged items, so it's often practical when direct observation is hard, but you must confirm the product truly represents the behavior you care about, and remember the same observable rule still applies. Your definitions and measurement must be anchored to things you can verify. When you're measuring occurrence, you'll usually choose between count, frequency, and rate. Frequency is just the total number of responses, while rate adjusts that count by time. And rate becomes especially important when session lengths vary, because comparing raw counts across unequal observation times can mislead you. A big exam trap is using frequency when the behavior is too fast to count accurately or when the behavior doesn't have clear boundaries, like off-task without a tight definition. In those cases, you often shift to sampling procedures or temporal measures so your data actually reflects the behavior in a usable way. Let's do the kind of quick math the exam loves. If you see 6 bytes in 30 minutes, convert it to a rate so you can compare across conditions. 6 per 30 minutes becomes 12 per hour. The same logic applies when comparing 10-minute and 20-minute sessions, and when measuring staff performance like correct prompts per minute, because rate keeps comparisons fair across different observation periods. Now shift to temporal dimensions. This is all about which time you're measuring. Duration is how long behavior lasts, latency is how long it takes to start after a cue, and IRT is the time between response cycles. The exam tip here is that time-based measures often show meaningful improvement even when simple counts don't change much. Duration is best when the behavior has meaningful length, like crying or engagement. And you can report total duration or average duration. Just be careful that you're measuring the length of the episode, not the time of day it occurred, and make sure your start and stop rules are explicit so different observers don't slice episodes differently. Latency focuses on response initiation, how long from an SD or instruction to the start of the response, so it's perfect for compliance, transitions, and task initiation. A common test angle is recognizing that decreasing latency can indicate learning even if accuracy looks stable because the client is starting faster and more independently. Interresponse time, or IRT, measures the spacing between responses, which matters in pace-related goals like DRL procedures or conversational turn-taking. Remember the direction? Longer IRT means more spacing between responses, and shorter IRT means more rapid responding, so you interpret change based on whether you're trying to slow down or increase fluency. Here's the big distinction. Continuous measurement records every instance or full-time dimension and is the most precise, while discontinuous measurement samples behavior and is more feasible but can misestimate true levels. That's why the exam keeps asking which method might over or underestimate, because interpretation depends on the method's built-in bias. A fast way to choose is to ask what you're measuring. For discrete responses, you'll usually use event recording for counting specific behaviors, or interval recording when the behavior is high frequency. For temporal dimensions, you'll pick duration for continuous behavior with clear start-end, latency for initiation, and IRT for spacing, and you always match the procedure to the critical dimension plus what's practical in the environment. When you design a discontinuous system, think like an engineer. Define the observation period and interval length, choose the procedure type, build a recording system and train observers, and then interpret results while accounting for known bias. Interval length is the lever here. Shorter intervals often increase precision but reduce feasibility. So the best answer is usually the one that fits the behavior and context. For interval recording, the exam loves bias. Whole interval only scores behavior if it happens for the entire interval, so it tends to underestimate occurrence and is more conservative. Partial interval scores if behavior happens at any point in the interval, so it tends to overestimate occurrence and can be useful for detecting change during intervention. So if you see which overestimates, partial interval is the classic answer. Momentary time sampling checks behavior at the exact moment the timer sounds, making it efficient for classrooms or group settings, especially when behavior is high frequency or evenly distributed. PLACHECK is essentially the group version, checking multiple students at the beep. But don't forget the trap. Brief behavior can be missed if it occurs between checks, so your conclusions should reflect that limitation. Let's lock in the rapid review. You learned how to write objective operational definitions with clear boundaries, how to choose among direct, indirect, and product measures, how to measure occurrence and time-based dimensions like duration, latency, and IRT, and how to choose continuous versus discontinuous procedures while interpreting bias correctly. If you want more exam-style practice, especially measurement vignettes and data interpretation drills, visit bcbamockexam.com and train the exact decision-making the exam rewards.